know, for those of them who have not heard about DataCog before, DataCog is a registered charity based in Edinburgh. It was founded in 2019. And since then, we have been empowering our community in different training, in different data, in different aspects of data. So in 2020, we are a joint winner of Data Fest for young learner age 9 to 19 in Edinburgh. Also, since we started, we have been able to empower over 150 people in different data training, both from our young learners program and also the adult. A lot of good news, of testimony of people who are getting jobs through our training. And so far, we have been able to create over 50 voluntary opportunity. And we are still creating more because our project is volunteer-led. So before we start, before I give the floor to my colleague, who is going to go through, who is going to handle the introduction section. I know in this house, we have people who are familiar with data, who are data literate. We also have some people as well who are not data literate. So this is an opportunity for us to test our knowledge on what our level of understanding our data. So I want us to do a little exercise, maybe for a few minutes. So I want us to go to, I want to share Kahoot for you, so I can do this week Kahoot exercise and to test our knowledge. So I wanted to go to so then I'm going to share the link to Kahoot that we're going to do now. So I want us to click that link and join the Kahoot. Give you this code number. Just hold on, please. Just waiting for the pin to generate. Okay. Okay. Okay, that's the code. Okay, I see one person. I'm still waiting for more. 2. That's Data Ninja. Sorry. Okay, let's go to yet 8. Thank you. Let's wait for another 2 minutes, then we can start. We're 11 now. Is anybody having problem to join? 12. Let's give him a chance. The name is Data Ninja. Data Ninja Challenge. Data Ninja Challenge. Okay, we're going to start now. Since we have 16 people, so I don't know what's up. We are 12. Don't know what's happened to the rest. 13. Let's give 14. 15. 16. Okay. That's the PIN number 29975. 7652. Okay, I think I need to start now. 14 plus, let's go. Time is running. Okay, ready, let's go. We are doing Kahoot exercise. Small quiz. For somebody who joined now, it's just a small short quiz. Join with this link. Please wait, just hold on a minute. There's somebody joining you asking question. Okay, let's go. Let's start now. Want to go? Yeah. Oh, you see my screen? Hello? Talk to me if you see my screen. Yeah, we'll start now. This is quiz 1. Information which is recorded so that you can go back, look at it later. Can be called what? Take your answer, please. 20 seconds, 19 seconds. Guys, be fast. 11 answers. 8 seconds. 4 seconds, 3 seconds, 2 seconds, 1 second. Thank you. The answer is blue, data. 9 people score, 9 people got the answer correctly. 4 people, total 6 people failed. Okay. Next, that's the table. The data ninja is on the top, which okay, which NEB, NEB on the top with 950. Okay, that's the scoreboard. So as we continue to do the size, so the scoreboard will continue to change depending on your score. Okay. Quiz number 2. Data can be grouped into how many categories? Red, 2, yellow, 5, blue, 4, green, 6. "18 seconds, 17 seconds, 15, 14, 13, 12, 11, 9, 8, 7, 6, 5, 4, 3, 1. Okay, 16 answers so far, and the answer is 4. And the 5 who got the answer correctly, and 6 said red, 3 said yellow, and 2 said green. Okay, let's look at the table again. See the score change. Yeah, Kenny is going on top. Okay, so that's how the table will be changing. Let me see. Sorry, a minute. Let me know what person is asking you question. You don't need to type the answer on the chart. You don't need to type the answer on the chart. Okay, the next one. Question number 3. Data that can be counted can be called what? Counted data, discrete data, categorical data, mathematical data. Three seconds go. Okay. Thank you. Well done, guys. 10 people got the answer correctly. And 4 said yellow, and 1 for category data, and 1 for counter data. So let's see that. Look at the table again. Okay. Kenya is on the top. Is it Kenya or Kenya? Okay. Let's go. That's the scoreboard. We're going to the next one. Question 4. What is the special name for categorical data? 2 options. Twin data, red. Yes or no, yellow. Binary data, blue. Male and female, male or female, green. Okay. Well done, guys. 11 people got the answer correctly, which is binary data, blue. 5 said yellow. Okay, let's look at the table again. Wow. Can I see on the top? Well done. Okay, let's be fast. Next question. Question number 5. Sunshine, Scotland. Ha ha ha. The measured temperature is 30 degrees. What type of data is this? Continuous data, red. Nominal data, yellow. Discrete data, blue. Binary data, green. Well done, guys. 6 people got the answer correctly. 5 said blue, 6 said yellow. Okay, look at the table again. Table of change. Carrying see on the top. Lulu has moved forward to the 3rd position. Okay, let's go. Question number 6. Your name, address, date of birth can be classed as what? Personal data, red. Household information, green. Private data, blue, and green. Digital footprint. Well done, guys. 15 people got the answer. So let's look at the table again. Well done. KCT on the top. Ulysses on 3rd position, and Data Ninja. Okay, let's go. Question number 7. What kind of what kind of data about you can be shared on social media without permission? Okay, 11 people got the answer correctly. Thank you very much. And let's see the table again. NEC on the top. Well done. Next question, question number 8. Which of these actions leaves a footprint on your data tree? Well done. 14 people got the answer correctly. Let's see the table again. Here on the top. Next question. Question number 9. Well done. Ten people got the answer correctly. Let's look at the table again. Olu have gone up. Second position. Okay. Let's go to the next one. Question number 10. Thank you. 5 people got the answer correct. And 10 people said red. Okay, let's look at the table again. Yeah, okay, on the top. Okay. Question number 11. Well done, guys. 16 people got the answer correctly. That's blue. Okay. My scoreboard. Okay. Next question. Question number 12. Data circle to consider in level 1 has many steps. Okay, thank you. People got the answer correctly. So let's go. Next question as this table. And question number 13. Okay, well done. 17 people got the answer correctly. First, everybody. That's great. And that's the table again. Well done. Next question number 14. Okay, well done. 15 people got the answer correctly. So that's the table again. Kenny on the top. Olu. Okay, well done, guys. So question number 15. Okay, 12 people got the answer correctly. Well done. So to question number 16. Well done. 30 people got the answer correctly. So let's look at the table. Wow. Okay, nice one. Still on top. Okay. Question number 17. Okay. 7 people got the answer correctly. The scoreboard. Although I've gone on top. Well done. Okay. Question number 18. Well done, guys. 12 people got the answer correctly. So let's see the table. Lucy on the top. Well done. Okay. Question number 19. 7 people got the answer correctly. Well done. Okay, we'll list on the top. Yeah, question number 20. Some people got the answer correctly. It's a histogram. Okay. I scoreboard, we'll list it on the top. Well done. Okay, question number 21. I think they should be giveaway. Twelve people got the answer correctly. Well done. Okay, let's look at the table again. Wow, Lucy on the top. Okay, question number 22. Well done. 14 people got the answer correctly. So question number, Lucy on the top. Well done. Question number 23. Okay, 30 people got the answer correctly. It's great. And the scoreboard, Lucy on the top. Okay, question number 24. Fake news or not? I don't. 6 people got the answer correctly. Yes, see on the top, Olu, see top. Well done, Olu. The last question, question number 25. Okay, well done. 6 people got the answer correctly. Okay, thank you very much, everyone, for participating in this exercise. Let's see who is our data ninja today. So the data ninja tonight is Mr. Olu. Let's clap for him. Oh, I don't know whether it's a male or female. Thank you very much. This brings us to the end of the exercise. So I'll stop sharing now. And is that okay, guys? Thank you very much for participating. Ladies and gentlemen, thank you for the exercise. And thank you for, can you hear me? Hello? 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 Is anybody hearing me? Hello? Okay, thank you very much. So that's the end of the exercise. So I just hand over to my colleague, Mr. Coker, who is going to facilitate the main part of the section. Thank you. So, Mr. Coker, over to you.
Thank you very, very much. Sorry, I was muted for a second there. I couldn't get my screen up or even be here. Good evening, everybody. I will try and share my screen briefly and we'll get to it. I hope I'm sharing the right screen. Can you see my introduction to analytics and data science?
Yes.
Cool.
Yes. Yeah.
What I have to do next is to bring up this one and then try my camera. It's going to let me show my face. Cool.
Yeah.
Good evening, everybody. I know it's quite late in the night now. Everyone is probably tired out and burnt out and ready to go to bed, or probably, in bed and just kind of playing the game whilst resting and all of those things. As you can already tell that I'm probably a quite bubbly person, and I'll try my best to make sure you don't get any sleep until I finish. So thank you very much for joining the session. So Chiklis mentioned my name quite a few times. I am Toriela Koka. I'm a data scientist. Sometimes I call myself an AI professional. I've been doing data for an upwards of 10 years. I have a master's degree. I've attempted a PhD, never finished it. I have worked with some of the biggest clients or businesses in the UK and across the world. I would say that I probably have, touched the entire life cycle of what you call the data science problem that businesses have today. Over the years, I've worked with different organizations. I've actually worked in an organization whereby we do half and half data analytics, consultancy business for clients and helping them to solve business problems. And then we run trainings as part of the business, and I actually deliver training. And sometimes I say to people who have probably delivered over 1,000 lectures to probably close to 2,000 people. I've worked with data analysts from, I don't know, where's my keyboard, to becoming a data analytics manager. Currently I work for one of the big 4 accounting consultancy businesses in the across the world actually, and I'm just in the middle of moving from one of those big 4 accounting consultancy business to a much more consultancy business in full scale. I know if you try and understand what I'm trying to say there's a difference between accountancy consultancy businesses and purely consultancy businesses. So I'm just in the middle of moving from one to the other. I'm sure if we get to speak or meet further on, I'll be able to share much more details about what I'm actually coding to you right now. So what are we here to talk about today? I see a lot of people on the session today have been doing some fantastic data ninja skills and throwing their weight around answering some of those questions. I mean, thank you very much for answering those questions. It shows a lot of, I can see a lot of engagement. I see a lot of people, answering questions, and I'm shocked now. And at some point, I'm beginning to feel that, am I really going to be able to do this presentation? But yeah, let's see. I'm not going to take too much of the time. I'm going to tell you briefly about what we are here to talk about, right? So the introduction to data scientists, or into data sciences that we're talking about tonight, I want to approach it from 3 perspectives. The first perspective being data. What is data actually? What do we do with data? How do we make sense of data? What type of data do we have out there, right? And then once we are able to touch that and we, get a bit of flesh around that and understand that, put that in proper perspective, we go into what is data sciences actually, and then what is the role of a data scientist. That's the approach we're going to adopt. So 3 parts. Maybe if I bore you too much with what is data, I'm sure you like the concept of data science. If you're not quite happy with that, you would love to know more about the role of a data scientist. And actually, one of the slides, I will be showing you what kind of salaries you'll be expecting, or people who work in data science actually get. So without further ado, actually, does anybody have any question they can type in, and I'll quickly answer them before we get on. Okay, feel free to type in your questions and I will attempt to answer them along the way. Brilliant. So let's get to it. Next. So what is data? All of you have answered many questions about data today. There is, statistics, raw information, and I put the word raw, and I didn't use just information. It's raw in the sense that on its own, it makes no complete sense, right? On its own, it makes no complete sense. We need to attach it to something else, take it through some level of processing to be able to make sense of that data and be able to, make decisions with it. So I put on the slide, I said it's facts and statistics collected for reference and or, interesting, collected for references and or for purposes of analysis to derive insight that can be used in effective decision making. So their decision making, you can make decisions, you can also make effective decisions. Those are 2 key things. When your decision is based on insights that has been generated from data, we tend to call such decisions, or we tend to assume that those sort of decisions are likely to be effective decisions, and we rely on them because they are facts, they are fact-based decision making. And where does this data come from? From different systems, on our social media, on devices, sensors. We even collect manual data. People take manual data to kind of collect them together for the purpose of doing further analysis and stuff like that. If you came from where I come from, my introduction to data, or the first time I see data being collected, was through manual entry. There was a bus stop, you know, somewhere in the city where I lived, and we, you know, as a kid, you know, when I walk past the bus stop, you will see some, you know, people those days, they will have a big spreadsheet of, I don't know what those kind of people are called, like statement, that the one they use in the bank those days to print bank statement, and then you see them writing things, how many cars passed, how many lorries and things like that. That was my first you know, introduction to what data is at that time. Maybe I didn't even know what it was at the time, but I know that data was being captured as, you know, as at that time. And you know, we know that even our devices where we work, you know, data are being captured from multiple places. And you know, the ability to be able to make sense of that data. How can you stitch all of those set of data together? How can you begin to generate insight from that data? How do you use that data to make an informed decision about a business? You know, is very, very important. I can see a question here. Someone is asking, what's the difference between a data scientist and a data science and a data analyst? I'll take that question later on. Let's go through this a little bit. I'll take the question later on. Or just simply put, a data analyst is more of a baby data scientist. So to become a data scientist, you also need the ability to be able to do some analysis first. You need to understand what that is. And then when you progress in your career, or you gather more skills and solve business problems that are data science related, you can then start calling yourself a data scientist. Or you may get a certification to say you're a data scientist. That's a short answer. We might expand on that answer shortly. So what is data? It's pure raw, you know, information that is yet to be processed. And we need to be able to process that data to be able to make sense and make effective decisions as a business. Why is that important? Yes, it's important that businesses make decisions, right? Business, you know, I mean, think about this pandemic, right? You know, the government will come on the screen almost every day and tell us there were, you know, 20,000 infections yesterday, and then somebody will ask them a question. So when is this lockdown going to be relaxed? And the government will say, well, we will take decision based by data. Once we are able to collect enough data that will allow us to make informed decision, we will relax the lockdown. And we saw that played out from about March or April last year when they started talking to us, because initially they weren't talking to us, and then suddenly they started talking to us. We see that played out, and then they say their decision is based on data. And actually, you know, the guys that were doing this modeling, they were fantastically very good guys, right? You know, when I'm going into deviating a little bit, but a little bit context makes, you know, makes this more interesting and keeps you away from dozing off on your bed. When this last lockdown that was, you know, that they set us free now, right? The infection rate was about 20-something thousand. And Boris Johnson was saying by the time they relaxed the lockdown and release us in, I think it was July the 18th or something, that the infections would have gotten up to 50,000. And you wonder, how do you know that? How do you know, we're just on 20,000. This guy is a bad guy, right? It's just 20,000. We're praying for it to come down. And you're telling us it's going to get to 50,000. What kind of man does that, right? It's because it's been advised by, you know, the data scientists who's been working through the data. And we actually saw that happen. A few days to that date, we saw the infection rate, you know, creep up to that 50,000, or even exceeded that 50,000, and then suddenly went back a bit. And you know, a lot of questions were being asked that if the infection rates were going up, why are we relaxing lockdown? You know, and the short answer is that they modeled it that shortly the infection will increase, it will peak, and it will stop coming down. That is a lot of work, and that gives me joy when I see, you know, we being able to use the data we have collected over the years over the period of time to make a prediction, and our prediction, is quite close to what really actually happens, it gives me a lot of joy. This information I have on the screen here is quite stale. Why is data important? 90% of data has been generated in the last 2.5 years. That's not true, because that was, something collected in 2013. I bet you if this analysis was done again, now, you probably realize that, 90% of data generated in the world today probably existed maybe in the last, 5 or 6 months rather than 2.5 years, because, a lot of data has been generated, over the years. And why we are all hungry to keep on generating data. Businesses want to know. Amazon wants to know who's buying from them. What are they buying? What sort of recommendations they should be doing? The NHS wants to know what is the figure about the prediction on flu for the winter will look like, so that they can make decisions, make staff available. The Sainsbury's of this world wants to know how, what is the buying habit of people now, and how do they plan post-pandemic to ensure that they have enough supplies in the store so that they can, people can get access to their shopping. Every business, regardless who you are interested in data. You want to be able to make informed decisions. You want to be able to make informed decisions on the data you have, right? It's very important. So basically, for every business, they need to be able to analyze the data they have to make informed decisions about the service they offer, the product they sell, the event they hold, even in the Tokyo Olympics, right? A lot of data is being collected and stuff like that. Now, how do we categorize this data? There's a lot of ways to categorize the data, but generally it's been agreed that we can look at them from two perspectives. The qualitative sort of category of data and the quantitative, sort of data. Let me push this away off my screen. Okay, right. So we can look at it from the perspective of qualitative and quantitative data. Now, if you talk about the qualitative data, it's basically maybe text or report or things like that, or even diagrams you have, maps and things like that. And it's usually very difficult to analyze, right? They are very difficult to analyze. And if you look at the way they are captured in terms of, putting them together, we'll get further into it. But of course, it is difficult to analyze. But that said, we now have some of the most intelligent tools in natural language processing and stuff like that now that allows us to be able to process even some qualitative data. I was building, okay, stop. So that's that about qualitative data. And then quantitative data, it's the one that most of us are quite used to when you have data in tables and rows, right? So Excel sheets, or even your Excel sheet, rows and columns. You have the name of the person, the address, the quantity sold, quantity return, and things like that, right? So you have the numerical data within that table of information you looked at, right? What I just mentioned, the name, the address, the quantity purchased, and all of those. You begin to see a bit of pattern, right? The name will be like a label, like a category, or maybe even the product, maybe is product category. Could be, if you go to Asda, it could be kitchenwares, or it could be utensils, it could be fruits, it could be vegetables, it could be that. That's a category of product, right? And then you could have, within that category of data, right, you may also have nominal or even ordinal. I'll talk about them in the next slide a little bit. And within the numeric data we know of, numbers usually, right? We have the continuous one and we have the discrete ones, right? Kind of data. So data in terms of the categories of data you can collect, they've all been grouped into two main categories. They are either qualitative or they are quantitative, Within a quantitative sphere, you then have a further drop down of categories or types or subtypes, categorical data and numeric data. And why is it important for us to be able to kind of differentiate between categorical data and numeric data, or even quantitative? Let's take it a step higher, quantitative and qualitative data. It's important because the kind of analysis you want to do, for example, you cannot be saying fruit and vegetables divided by kitchen utensils. That doesn't make any sense, right? Or pawpaw divided by, apple. You can't do that because that's a category, right? I cannot do that. But I can say, okay, the quantity purchased, what is the proportion of the quantity purchased against the total value of sales made, right? So how much, what was the proportion of the quantity purchased by somebody against the total sales that I got in that particular day? So I can tell her, oh, what's that proportion? So this person actually bought 2% of my total sales today or something like that. Because that's in numeric data, I can analyze that, I can add, divide, multiply, and all of those kind of operations on numeric data. I wouldn't want to try that on categorical data. And it's important we make that distinction, not just because we want to do operations, but also when we start using statistical tools, maybe like Python, R, or SAS kind of tools, to want to make sense of that data, to begin to generate insights, we have to be able to plug in the right data into the system. Otherwise, everything will fall apart. If we go further on to try and, all right, okay, I missed that one. Okay, that's fine. If we kind of look at the bottom layers, we have the nominal, ordinal, discrete, and continuous kind of data. Continuous data, right? It's not in this list, but things like revenue, maybe even age, they are continuous, right? But if we look at data in terms of the scale of it, right? Scale of data, which basically tells you, okay, sorry, somebody just put video on. I thought they were saying something. So you have the scales of data. Within the scales of data, you have the nominal, ordinal, interval, ratios, right? Now, the nominal data basically has no sort of ordering, right? There's no there's no importance to one to the other, and it's just like that. So things like that, you have number assigned to a runner in a race, exactly, right? So in the Olympics, right, everybody lines up, they want to run. There's a number attached to everybody on that on the track. It doesn't mean that one number is more important than the other. Even the football field, right? Everybody has a number, is playing 9 or 2 or whatever, right? But none of those numbers may, well, maybe the goalkeeper is more important, right? But the point I'm trying to make is that when you look at nominal data, there is no importance to how the order which they have, and that takes us to the order, the ordinal kind of data, where it's important that we know the order of that data. For example, who took gold, who took silver or bronze within that participation of that event. That's important. And then you have the ratios, which I talked about earlier on, which was the proportion of a total. And then you have the interval. Intervals are more, okay, I think I have some examples here. You have like, temperature, you can take a, temperature of a period of time, and then you say, well, the temperature ranges between 20 and 50, or maybe from 5 to 10 or something like that. That is the temperature of that particular area. It doesn't really come with maybe this is, and the term often used is that there's no true zero, right? It doesn't have a 0 point or something. It's just an interval of event or numbers. Even the kind of data you collect from a weather station, which is generating information, sometimes might be an interval kind of data. Ratios, we talked about ratios, a proportion of this is that. And okay, I've also put on the slide as well. So when you look at the scale of the data, you can see the type. So nominal data are more likely to be discrete. Ordinal data are more likely to be discrete as well. But interval and ratios are more likely to be continuous data, and a little bit more information on the right there. Am I going too fast? Am I putting anybody to sleep? Yeah. Have I achieved my purpose of trying to put people to sleep? I think I've done it. Nobody's even raising a comment saying, no, I did not put them to sleep. Good. Maud says, they are following me. That's really good. At least one person is awake. Is it just one person that is awake then? That's not fair. I thought we have up to about 42 people on the call. Only one person is awake. Wow.
Yeah, we are following.
Okay.
Yeah.
Cool. So don't worry about early. What we're just basically trying to do here is that we're trying to help ourselves understand a little bit more about data before we start talking about data science. We can see the kind of data we have and stuff like that. And then when you look at the structure of data itself, you can have structured data, semi-structured. You can also have unstructured data, right? So a typical structured data means that it has a structure. What do I mean by that? Rows and columns are well defined. And then if you go to the other extreme end, or extreme rather than extreme end, you look at unstructured data. If you think about the kind of information that comes from machines, you just see numbers 0011, something like that, that is collected like that, and almost impossible to analyze that kind of data. But there are clever systems that have been designed to be able to make sense of that data, right? And then in between the structured and the unstructured, you have the semi-structured. If you think about some of your social media posts, some of them can be classed as semi-structured. Some of them may even be unstructured. If you use all emojis, right? Laugh out loud, LOL, and so on and so forth, we can't really distill what you're saying in that. But if you mix that with some words like, okay, I'm quite excited, and then you put your exciting emojis to it, we can see some sort of patterns around that data, and we can make a little bit more sense of it. So if you think about structure of data, any data that can easily, you look at it and you can see, okay, there's a pattern to this, or there's a structure to it, it's more likely to be structured. And then if you look at another set of data and it happens to be something that, what is this? What's this? It's more likely to be unstructured data. And then if you be like, oh, it looks like, you know exactly that it's somewhere in between those kind of data. But often when we are working with data, you might have to work with, these three sets of kind of data, and you have to devise a means of being able to make sense of them. And that's why we're data scientists, right? We're supposed to be able to work with any kind of data and be able to generate insight from that data to support businesses in making their own decisions. And I'll go to the next slide. So in terms of, classification of data, some data are classified as open data because, they are available to everyone. We can reuse them, we can, and so on. And then you have public data and private data as well. Obviously, private data is private. In terms of this classification of data, I'm quite conscious to use the word, open and public, although it's, data is often classified like that. But we have to be, satisfied that, we are not breaking any GDPR rules. We are not breaking our organizational rules, or maybe we are no longer in EU actually. Maybe Data Protection Act of the UK, and GDPR will still be active anyway. So, what does the rule, whether GDPR or Data Protection Act, say about the data I'm working with? I need to be conscious of that, so I'm not breaking rules. And some of those rules, when you break them, it costs the organization quite a lot of money. Sometimes people may actually get in trouble on their own for misclassifying data. So yes, data is out there, and I'll show you examples of where you might be able to find some of this data out there to use for your references of practice and things like that. But I'm saying that, yes, that's the case. You also make sure that you are conscious of the regulations around data usage. Open data is freely available, can be used by anyone, anywhere, for any purpose. And you can reuse it. I'll show you some examples of that shortly. What are the types of open data that we have? You have some data within museums, libraries, and archives, outputs or maybe journals of scientific research that has been published and left in the open so people can collect and reuse them. Sometimes you might also need, although the data is open, you might still need to get authorization to be able to access that data actually. Weather data, there's a lot of weather data out there as well that is open, you can reuse it. And so many all kind of data. Why is it important that there are open data out there in the market? Because for example, it allows the society to kind of go on. It allows so I was sometimes last year speaking with a company in the UK, and what they do basically is that they try and collect a lot of open source data within social media and other sources. They try and put all of those data together and make some sort of alert system for the airline industry, basically, right? So what am I talking about? So if there was a flight risk, or maybe there's something going on in, example, Afghanistan, and however, yesterday, there wasn't a particular city somewhere there wasn't a big issue there, and so flight can still fly past that city, and suddenly there are indications that there will be issues there. That may not be quickly picked up by the mainstream media, and so the airline may not even know, and they might fly past that particular city, and there might just be trouble. What this company does is that they are collecting data from every source possible: Twitter, Facebook, everything. All of those sort of open data, they collect them together and create an alert system. The moment there are risks, obviously they've coded the data in a way that potential risk can be identified within the chunk of data collected. The alert system, alerts this company, and they also have a way of, alerting their clients, and a lot of airline organizations across the world actually subscribe to them, so that they get that data as soon as developments are happening in those places where they are flying through, and then they can redivert, or they can divert their flight paths such that they are not. So can you guys hear me?
Yes, we can hear you.
Cool, fantastic. So that's an example of one of the benefits of data being open. If we are unable to collect such data, please, what is the difference between open and public data? Will show in a second. Last slide, please. Would Android be open data? Mobile operator. Would Android be open data? Android is an operating system. Give me 1 second. Android is an operating system.
Android is an operating system, and this can't be the data. It can't really be open. It's not open because if you don't have access to, if you're not in Android, there whatever the information the Android is there, you will not have access to it. So
I think the question is not framed. I think they're looking for something more. Would Android be open data? Would Android be open data? Okay. I'll try and guess what that question is really talking about. So there are open source out there that gives you the, I need to change this headphone. This one is a bit noisy now.
Okay.
Hello?
Hello?
Yeah, can you hear me, right?
Yeah.
Fantastic, thank you. I had to change that headphone. So open source, in the sense that the scripts and the, what's it called? There's a name called, that was used in creating the operating system can be available for you to recreate it. For example, maybe on GitHub. The source code is called source code. Okay, now we're getting many. So I'm trying to address the question, would Android be open data? The source code that created some of those Android devices can be available. Now, but are you going to have access to the source code that created my Android device that I'm using? No, you wouldn't have access to that, right? So, and then,
sorry, let me come in at the moment. If you look at Android, to me, I see once you have access to Android on your phone, you have it as just a personalized information.
Yeah,
so
yeah.
I don't see it as an open, the data that's open to everybody, but it's personalized informations or personalized data that you are going to find in your own Android.
Absolutely. So your Android is personal to you. Nobody's going to be getting the access to whatever information you have there. However, like I said, the operating system, which is Android, I think you might find some open source libraries that have the source code that is used to create the Android operating system itself. If you're interested in that level of work, you can find out more about it. However, like Mr. Dodo has mentioned, the device you have to yourself is to yourself. Nobody's going to have access to that. How do you verify a fake news when you pick information from open sources like Facebook, Twitter? I think the first thing you need to first understand is that, how do you know if it's even fake news in the first place, right? So I think there are a number of websites now that are actually helping to, if you put in an information there, it will tell you whether it's fake news or not. I can't remember with one in particular. And that's where the responsibility of those social media organizations are, to make sure that they bring down fake news. Fake news is a problem that has that's come to stay. It's one of the unfortunate benefits you get out of having everybody have access to devices to type as they like.
Let me chip something here. Sorry, let me chip something here. Fake news, for example, you look at what kind of news is that. When you define the kind of news, you're able to know, okay, what's supposed to be the actual source of this news. A typical example, like somebody said, pounded yam kills hernia. You look at where the publication is coming from. Is it coming from a medical research? Is it coming from a medical journal? Is it coming from WHO or World Health Organization? So once we're able to know if that information is coming from World Health Organization, you actually know that news is real. It's coming from the right source. But if you look at it's not research based, and you look at it maybe from Facebook, that exactly tells you that that is a fake news. So first of all, define what kind of news is that. What source of the information is supposed to get that news to be able to determine that this is a good news. For example, if you're talking about football, you look at BBC, you look at Sky Channel, all those watch channels. But anything outside there, and that's not research based, is fake news.
Thank you very much. So basically, where is the source of the information itself? Is that information coming from a widely regarded source, before you take on that information? But I'm also quite aware that some information come and they appear to be so genuine, and it's really hard to tell whether it is, genuine or not until you dig further on. And that's what I'm trying to say here, is that yes, verify the source. Can you take a step further? Actually, I had one information sent to me recently, and when I looked at the information, I looked at the website. It was showing a government website and all of those things, and I was like, this cannot be from a government. So what I basically did was copy that same information and put it back to Google. And then I realized that a lot of people have commented on that. So sometimes, just putting it back to Google, for example, might just help clear the issues. And then as well. But verify the source, very important key given to us by Mr. Dodo. Okay. When data is open, there's a lot of innovation that can be gathered. I think, if I'm not wrong, a lot of the IPs that Tesla had when it started, right, they were not patented. So, which basically means that you can actually go there and have access to the, all of the IPs they created. And, it's, I don't know if they changed that policy now, but when it first started, a lot of their IPs were not patented, which basically meant that people can go ahead and have access to it and use it. But I'm not sure they ever had that issue with anyone do it. So, but the idea is that it allows for innovation to grow, innovation to happen in the world, and the world becomes a better place. Well, and at the same time, people then take advantage of that to do something else with that level of data that is available. Yes, public and private data, there's a lot of data out there that are public, but you may still have restrictions on whether you can use it or how you share it. Meanwhile, private data is so sensitive that you cannot share. You may not even have access to it, right? I was working for a client recently. For me to get access to their data, they took every possible information about me. So from myself, I'm married, my kids, my siblings, their own children, where they work, everything about them, but about my family, and as far as they could get, because the data I was working with was quite sensitive. Is a lot of private data, such that if anything was to go wrong or I did something, they want to be able to have access to me as quickly as possible. When I made access, you know exactly what I'm trying to describe there, right? So at least they have information about the address of my siblings, my family, my in-laws and things like that. So somehow they will be able to find me within a cycle of all of those people, and it's quite rigorous, checks. Even did counterterrorism and a lot of things, so that they can manage me if I was to do something, right? So, and that's the height of data that is private. You cannot mess up with them. So most of the organizations you work in that deals with customer, for example, or deals with HR data, is also a very sensitive one. You cannot mess around with those, right? And then let's look at some examples. Somebody was asking me, what is the difference between open data and public data? Now, there's a little bit of time, there's a tiny line in between those two, right? When you talk about open data, there are data that when I go online, I can just search for them, I'll find it. Now, the same thing with public data, I can find it online as well, but I may need to be a member of a particular group. For example, if I want to say Amazon review, I may need to log onto my Amazon account or something like that to read the full review and things like that. Meanwhile, open data, if I just go online and search for it, I don't, most times don't need to have any sort of restrictions on how easily I access them. For example, the data.gov UK, that website that does everything from business to childcare to schools to university to loans to visa, that data.gov.uk has everything, right? So it's open. And also there are a lot of data also posted on the NHS websites, whether Scotland or England, as the case may be. And we talked about uh, uh, private data already. So my attempts in this first few slides is just to give you a little bit of perspective, just to top up what you've done in the Kahoot around what data is, and what sort of categories we have of data. How do you measure data itself? What kind of structures can data come in? And what sort of classification are there? Usually this set of data we put here, a lot of people use it for practice projects, because some of them are quite very rich, that you may be able to glean a lot of insights as somebody who's still learning to become a data scientist. So sort of if you think about the COVID data as well, right? It becomes very handy. You can actually download historical information about COVID cases in the UK, and I think in the US as well is actually out there. And a lot of people have developed things on those bases. So I'm going to move on straight to let me see what I've done here. Okay, to data science, right? What is data science? What is data science? Okay, what have I done here? Give me a second. Okay, so we're talking about data science now. What is data science? It's one second, guys. Give me a second. I think there's a background coming. Sorry about that. It's an interdisciplinary field that use scientific methods and processes, algorithms, and systems. Put short, right? Data science, is a field of data analysis that tends to carry along a lot of the scientific method, within the science world, and bring this method, coupled with statistics, a lot of statistics, and the processes adopted in the science world into data analysis, with the intention of generating robust ideas and insight from data that we have, in order for us to be able to make effective decisions. That's it. It borrows a lot from the science world. So when you talk about hypothesis testing, what is the process of generating an hypothesis? How do you test that? How do you validate that? How do you look at correlation? How do you look at the validity, the specificity, the how do you validate that information? All of those scientific methods are brought into data analysis to for us to be able to do a little bit more than you would have done with data analysis. And maybe it's a good point for me to also talk about a little more around the difference between data science and data analysis. While the data analyst will focus a lot around generating visualization and dashboards and reports, and a lot about basic if you like, management information reporting. A data scientist, yes, I've had to do that as well myself, doing this kind of work. But also I want to, as a data scientist, I go a little bit further on beyond um, the data analysis that I've done or the dashboard I've built, because those are usually historical information. So what is our total sales? in the last 5 years? How do we put that on a dashboard, a flowchart, or sorry, a dashboard or a report, a PowerPoint presentation, or anything like that, that gives us an idea how we've been doing in the last 5 years? You're more looking at historical kind of data and less about what is happening now and what is going to happen next. Now, the people who specialize in historical data and projecting that out, you often look at them as data analysts. But the moment you start looking at making a prediction into the future, working with big data and unstructured data, you've already gone away into becoming a data scientist, because the kind of skills required at that point is quite different, it's quite vast, is a lot. And that's why when I show you later on now, you see, sort of expectations that you have when you start doing the work of a data scientist. So, I mean, you might have read through the slide, but I can read it. Data science is an interdisciplinary field that uses scientific method, processes, algorithms, and systems to extract knowledge and insight from many structural and unstructured data. Many structured and unstructured data. Data science is, related to data mining, machine learning, and big data. If we were to be in a data science classroom right now, I would expand that even further on, right? I've done a little bit of expansion here, but that's a different way to expand it even further on, beyond the 4 8 I have on the screen. But, a bit of introduction, data engineering, data visualization, deep learning, and each of these areas are there are areas you can specialize in. So you can say, well, I want to be a natural language processing expertise, right? That's what I want to dwell on, right? Or I want to be a deep learning expert. So or I want to be a machine learning expert. I want to be doing supervised learning, unsupervised learning, and reinforcement learning and things like that. Or I want to be a data engineer. I want to build data pipelines that allows anybody who wants to do analysis can pick up from the pipeline to do the analysis. Anybody who wants to go into data sciences can pick up what from my pipeline to be able to do their data science predictions. Or even people who want to do natural language processing from my data pipeline, they can extract data from there to make sense of that. You can do anything around the depending on the area you focus or you major in. But generally you want to have experience across all of this. And what you also observe is that data visualization is still part of the data science piece, right? Because when you do all of these exciting predictions and blah blah blah, you still see the government guys, right? They'll still plot charts and tables, right, to show us, oh, this is the trend in the last week, but we project that this will be the trend in the next couple of weeks time, something like that. So you still must be able to do what a data analyst does as a data scientist. Application, we've talked about COVID, that's health industry, is applicable in retail, manufacturing, in financial services, anywhere at all you can think of. Data science is applicable. Data science is required in all of these industries for businesses to make decisions. And what that basically tells me is that if I was to be a data scientist, I can apply my skills. Right. Okay. Thank you, Mr. Dodo. I can apply my skills across, different industry as a data scientist, right? As a data scientist, if I was a data scientist, my skills will be required in different industries. I am not restricted to a particular industry where I can work. The options, the opportunities that exist for me is quite massive, in the sense that everybody wants a data scientist to do something for them. This is data that is available on IT Jobs Watch. You can go to IT Jobs Watch. You can get the current information. When I put up this slide, prepared this slide, I took information from it. Was so, as at February 2021, I did it. So if you were to do it today, you probably find the one for last month or something. You can see the right. You can see the trend for data scientists, right? And the median annual salary for a data scientist is about 65K. And you can see the salary going as far as 100K and more. Well, depending on where you are. If you are outside of London, there's a little bit of variations in the value that you get. But it gives you a sort of a general idea of what sort of salary expectations you would have as a data scientist. Job offers, what kind of skills are they really looking for? Python, data analytics, data scientists. People with Python skills tend to get um, uh, a lot of opportunities actually. So the role of a data scientist, yes, all of this data we've been talking about from different devices, businesses and so on and so forth. Organizations need somebody to help them work with that data, to make sense of that data, to allow them to make decisions. Businesses want to make decisions. They want to know how their supply, chain looks like. They want to be able to make decision on COVID. They want to be able to. So somebody has to help them analyze that data so that they can make effective decision. That's what you do as a data scientist. Some of the key activities you have is that you extract data from different systems wherever they are. When you extract this data, they may be purely very dirty, and I use the word dirty, right? You need to cleanse them, you need to manipulate to, wrangle the data and be able to, um, generate insight from it. Before you can do that, you then go on to, well, I might be extracting data from multiple sources, right? From a system here, a system there. One of the recent project I actually worked on, um, I was pulling data from about 20 different systems for this organization. And this system don't talk to one another, and they hold information about their customers, right? I need to be able to pick up the data from one system, clean it, connect that data to another system. It's a mess. So you often have to integrate data coming from different places, and you oftentimes have to also transform that data. For example, I may have just the date of birth, right? That date of birth, I may be able to kind of transform it so that I have like age of the people, and maybe even go a step further and say, okay, let me put them in age bands, because it's easier for my analysis to focus on age bands, children, middle-aged, adult, and seniors, rather than 10-year-old, 12-year-old, 13-year-old, 16-year-old, and so on and so forth. You get my point. And then you analyze that data, okay, so that you can develop insights that can be put onto visualization. So these are some of the little bits you do as a data scientist. A lot more, actually. So as a data scientist, I have to stop any moment now. I'm wrapping up. Actually, as a data scientist, you exist to solve business problems. Um, some of the problems you solve are descriptive analytics problems, whereby businesses want to know what is happening in their business. Some of them are diagnostics in terms of, why is this happening in my organization? So I've asked the first question, what is happening? Okay, I know what is happening, but why is it happening? Some of your work might have to do with both. And then you go a step further. Yes, I know what is happening. I know why it is happening, but what is likely to happen? What is likely to happen? And then once I know what is likely to happen, I may then go further on to say, well, can I preempt? Can I make decisions or control what is likely to happen because I have that information? So you start, looking at, how you almost change the future without being in the future, actually, right? So you start looking at prescriptive analytics. So if you look at this chart, it's saying a lot of things, right? It's talking about these activities. If you're just doing descriptive analytics as an organization, what sort of value do you bring to your business, and how mature are you within the data spectrum, right? It looks like you're a little bit down. Now, if you go further on, as you go higher and higher, you're able to generate more value to your organization, right? You generate more value because you're, generating more insight that has more value to your organization, but also in being able to do that, there's a lot of complexity around that process. And that means that if I was brought in as a data scientist, the business expect me to have some, technical skills that will help them generate value to their business, and regardless of how complex the process is. I'll stop here and I'll take further questions if anybody have questions for me. Back to you, Mr. Chooks. I'll let you moderate the question.
Yeah, thank you very much, Mr. Coker, and thank you for our learners today who joined this section. And I hope you all benefited from this brief section. There is a more to data science, but it's doable. There's no panic, but the good thing is that there is a very big aspect of data science. So you can just pick one aspect, you can specialize, and you can earn a good living from it. You don't have to be here and there. Even somebody working as a predictive analyst is another big group. What do you do? How will we be able to say, okay, organization, for example, if my business sells ice cream, the people working there will be able to say, okay, looking at data forecast, use that data forecast to be able to predict how many ice cream they're likely to sell on the day that the sun is temperature is heating up to 20-25 degrees. So those are kind of rules and things one can do with data. So the floor is open for little questions, and if okay.
So just to add a little bit to what you just said, Mr. Dodo. So if I hear you correctly, you want me to expand on the fact that you don't need all of the skills possible. You're not going to be perfect, 100% perfect, right? So there are level of skills you have that is just enough to get in the market, in the job market, and you get paid for that, right? And then as you build on that, you get more experience, you move up the ladder. And so oftentimes people don't know that you can be ready without being an expert, right? You just need enough that gets you through the door, and you build on your experience, you get better at this, and you kind of move on. Okay.
Yes,
Looks like
sorry,
there's
somebody
plenty of
asked a
questions here.
question. Yes, a question here. Yes, definitely. From the internship program that will start hopefully by September, we'll have that intro to be able to give people understanding sort of data source and some of the tools that we use in this data, like what Mr. Coco have mentioned. There are so many sources that you can get your data. So they are open source. There are also restricted source that you need to register to have access to those sources to be able to use those data to, for example, you want to look at customer insight or customer review of a particular organization. Sometimes you need to have access to be able to use those data to do whatever you want to do. So those areas will be covered before we start the internship. Internship is going to roughly take 3 months. And yeah, there's no exam. All we need to do is a project. Project is data is about skill. So those projects we're going to do in the internship is something that somebody can evidence when you are looking for a job. So there will be no exam, but people will be engaged in a project that you can show. So how do we know that? Do you need coding skill? Yeah, coding skill. No, it's what we call in data is Python, which is a little bit about programming as well. So that skill is good. Those who have the Python skill are hot cake at the market at the moment in data field. So if you're able to capture that Python skill, I think you are good to go. You say, how do I know when I'm
really, if you want to be
go ahead.
Go on, sir. Go on, sir.
No, you just go.
If you want to be a data scientist, you need one programming skills. You do need one programming skills if you're going to be a data scientist. It's simple. To what extent? Just enough to get you in the door. I'm still, not a perfect at Python. So, and I've been doing this for years, right? So, but you need to have programming skills, Python. Sorry, Mr. Dodo, please carry on.
Yeah.
Or you want to answer more
No,
questions?
say, what would you like some more details? Yeah, definitely. Before we start the lab what we call lab session or the internship, everyone will be introduced to different tools we're going to use. Like you mentioned, labs, the internship, we might decide to use Power BI, decide to also use Python or use SQL. So definitely we have that introduction before the internship, or what kind of tool are we going to use throughout the internship. So don't worry, those information will be provided for you. So data source as well, we provided. We'll have that introduction section for the internship, so that everyone will be familiar with the tool we are going to use and what is expected of everybody participating in the internship. Any other question? Yes, and yeah, we are going to, it's not only Python, the SQL is there. We also have the Power BI. So, but I will let you know when we are going to start to how the structure of the internship is going to look like, and because what we are working on depends on the kind of tool we are going to use. Say, which programming language would you recommend first? Well, I wouldn't recommend anyone, but all I can say is just hold on. We will have a section on the 22nd, the second section of this data analysis, data science. So we're able to talk more on those languages and sort of data source, and also the tool. What project are we currently working on? We have different projects. We have different projects for different training. Like in Edinburgh, we have training, a lab session that people are working on different projects. So what they are working on there will not be the same thing, maybe different from what they are going to work on the internship of this internship, because this is taking up to 3 months. Any other question?
I think while I'm still thinking of question, there's a number of tools you would use to do data science. I didn't mention any of the tools because I think there's going to be another session that will cover a little bit more about the practicality of how this internship will work and all of those things which you become aware of. But to give you a quick view of some of the skills that you would require, that is often required of a data scientist, right? I put them into 4 categories, right? One is basic data analysis tools, right? Something like Excel. It's quite basic, right? And something like, if you know how to use it, it's not that popular anymore, VBA, right? And then I talk about the data preparation tools, right? And you see me mention some tools twice, right? For example, Power BI. Power BI is both a data preparation tool and also a data visualization tool, right? Data preparation and a data visualization tool. Power BI is an example. Tableau as well as one, a data preparation tool and also a data visualization tool, the data Tableau prep. Have something we call SSIS. If you SQL Server Integration Services, SSIS. It's a data preparation tool. There's something called Alteryx, right? Alteryx. It's also a data preparation tool, to prep data pipeline and things like that. And obviously, right, the visualization tools. So I talked about basic data prep, talked about the basic data analysis tools. I talked about the data preparation tools. And now I'm talking about the data visualization tools. That would be Power BI, Tableau, Cognos BI, ClickView, Spotfire, a lot of them, right? And then the fourth section one I'm talking about is a more general data science tool, right? There are a number of them. So you have Python, you have SAS, you have R, you have MATLAB, you have, there are a number of them, but the most popular within the data science tools really is R, programming, and Python. Now, Python itself is a giant tool because there are different applications of Python. You can apply Python in data science. You can apply Python in web development. You can apply Python in software development. You can apply Python in multiple places. You have to be conscious that the Python you're interested in is the Python for data sciences, right? So, so I thought I would just add in a little bit there. Have I dragged us into more questions or confusions? Would you like some details on the software types of data sources that we'll be working on? Which programming language will you recommend first? Okay. At the end of the internship, Mr. Dodo, what it does. I was thinking we would do SQL, Power BI, and Tableau. Yes.
Yeah, yes.
I mean, that information will be shared, but we you put them on. Yeah, I didn't miss anything then.
Yeah, there is absolutely, there is a lot to know before you have that internship program. So I would say don't worry at the moment. We are going to provide more insight to the program by next section on 22nd. It's also give you opportunity to ask questions. And when we start the labs, when we start the internship as well, there will be introduction part of it to be able to give people understanding of what is required in that project, what we should be doing, and expectation. And our tutor will also be available to support people throughout the internship. So we have all the resources to be able to give you all the things you need to excel in data program. So don't worry. I think we thank you very much, everyone. In absence of any further question, I will hand over to Mr. DG if you have anything to say. And I will encourage you to turn up on time on the 22nd, where we're going to have another section. And that section, we are going to dig deep into so many things to prepare every one of us for the internship program. Thank you very much. And God bless you.
Thank you so much, Jukes, for and Tirola. Thank you guys for that. So for those guys that is interested in the internship, you need to apply as soon as possible. Actually, like this guy is expert in what they do. And another thing I want to also let you guys know that for those guys that have already registered for Blue Sky program, you might not be able to do this program, right? So you need to enter this program specifically. So I would explain that further in when we have the next section, so that we know how this is structured. So this is a top party program. Let me just say it that way, right? So it's not kind of, so even though we provide the platform, but DataCalc is doing this particular internship for this particular purpose. So so next week, when we do the next introduction, we would explain further on this one. All right, thank you, everybody. Have a good evening. Good night. Cheers.
Thank you. Thank you, Mr. Deji.
Good night. Thank you. Bye.
Yeah.